Right, so today we have two speakers from Schaeffler Group. So first, Christoph Künster, who is an expert data architect at Schaeffler, and he is very experienced in data-driven product development, machine learning, automation, and IT. And he leverages a unique combination of traditional mechanical engineering, contemporary information, and communication technologies and data-driven methodologies. He's passionate about driving the digitalization of companies and facilitating their transition into the digital era. Welcome, Christoph. And second, we have Sven Pelzer, also from Schaeffler, and he's a solution architect at Schaeffler, and he boasts a career in software development over a range of domains and has been involved with the development of the digital twin offering of Schaeffler. Yeah, welcome, Sven. And with this, we will transition to the presentation session. So the floor is yours.
So Sven and I will give you a presentation today about advantages and challenges of the Web of Things for digital twins at Schaeffler. Before we start, the introduction already happened. Sven and I, we both work in the digital twin department, or let's say in the twin group, where we try to shape the digital twin at Schaeffler. This is kind of, located in a department which is called Data Science and Software Solutions. So this is basically also the umbrella where we work and also where we work and also which kind of goals we work and visions. Before I jump into the topic, I will introduce Schaeffler in a nutshell very quickly. This is kind of mandatory and I will do that. So, and then we come to the of the WOT standard, which we kind of implemented in digital twins. And Sven will then take over the challenges which we have currently with the standard. And then we phase out with a Q&A session. So maybe not all of you know Schaeffler. Schaeffler is a company which is producing mainly metal parts, but also for sure components which are of mechatronic kind of nature. I think the most famous product you know from Schaeffler are the bearings. This is what you see on the very left side. Usually these products isolate rotation, so everything which rotates or moves, usually you find a Schaeffler product or you find a bearing which you produce. And that you can see that it's going really from a small size. So really maybe the smallest bearings you produce are in the drill of the dentist. And the biggest one, maybe you know London, and the London Eye in the Thames is next to basically the London Eye. So the bearing in the London Eye, this is also being produced by Schaeffler. This is also the dimension you can imagine. So these are really heavy, and we produce these parts also in our plants. So this is the second image that you can see. This is heated, and they apply heat treatments and anything to make these products last. And on the very right side, you see it also in wind turbines, basically. So everywhere, everything which is rotating, usually find Schaeffler products, especially the bearings here as an example of a wide range of products. Then some figures about Schaeffler. We are roughly 80,000 employees worldwide. So we have 200 locations in 50 countries. We have 76 plants and 20 R&D centers. So you see that Schaeffler also focusing basically not only on producing and selling products, but also on the further development and also approaching new fields where also we think that digital twin is one of them. The sales in 2020 were roughly 60 billion. The EBIT was 6.6%, and we have this is something also what Schaeffler is pretty proud of. We filed and registered roughly 1,250 patents last year. So this also means we try to be innovative and also inventive, this is also what drives us in the end. This said, we jump into the topic of digital twins at Schaeffler. And I will guide you a little bit through the journey we made with the WT. But before that, I will quickly define or say something about what Schaeffler thinks a digital twin is. So if it comes to digital twins, you hear a lot of buzzwords usually, and I like this picture here, the blind man and the elephant, because this is the kind of picture which shows this discussion. So if if people stand in front of this big elephant, depending where you stand and what you see, you interpret it differently. So for instance, the guy here at the foot, it interprets this elephant as a tree. The one in the front says this is a spear, and the guy here which is sitting on top of it, it's a fan. And usually the same thing is also if it comes to the digital twin itself. So usually each company on each department defines it differently. So it could be a 3D model. It's also often said it's a simulation. So you apply simulation on top of products, and then you can predict the behavior of products. And this is exactly what a digital twin is. For many people, it's also IoT data. So you can only know how a product behaves if you measure what is really going on in the field. So if you talk to other people, again, it's a data model. So all the AAS community, for instance, they say that twin is exactly that. And if it's coming to different domains, they all state this is the digital twin. And we tried for Schaeffler also to define this, but before that, what all of these kind of definitions have in common is that we try to create a kind of product-centric view to cover the whole product life cycle. This is usually the main intention if it comes to a digital twin or digital twin representation. And why do we do that? This is not something we do because it makes fun. Usually all of the people who are working in these kind of fields do it to increase their revenue, so to get new business opportunities, and also to reduce the costs, to do a kind of internal optimization. I mean, this is basically what you do if you apply new things, or if you develop new things in the end. And that's why we also at Schaeffler, we defined a digital twin for us as a digital representation of a physical thing, so to say. I mean, this is a not concrete definition, so to say, but this is exactly what we tried to do and did also with the WOT standard in the end. So we do that because we still think that the digital twin in this definition will be a driver to optimize and enhance Schaeffler products in the end, to increase revenue and reduce costs. And if you do so imagine you map all, let's say, everything you know about a product, then you will create a kind of representation of the products in the cloud. This is here visualized with this nice mesh or network on top of it. And you can imagine what we basically also did. We really want to have each product which is being produced kind of represented. However this looks like, this will be, I will talk about that a little bit later, so that we know everything about this product, either what kind of properties, what kind of state it currently has, so that this product exists in the end, so that we know about it, that it exists. And maybe if there are sensors attached, we also want to interact with the sensors. And this is why we came to the WOT standard in the very beginning. This is a slide where I tried to answer why we really went with the WOT standard, because it reflected exactly that. So we wanted to have our products centric. This is basically here bearing in a wind turbine. We wanted to map all the properties of this product. So we wanted to know all these properties, and we also wanted to interact with this property, and we also wanted to know what is really going on in this product in the end. And maybe if you think about this trivial, so to say, big bearing which is living in a wind turbine, this is not only made of steel. So this is what you see on the left-hand side. There's an animation also already going on. Hopefully, this is pretty fluent or not chopping at your side. We attach a lot of sensors to this product. For instance, we wanted to know about the lubrication, the condition of the lubrication. We attached also load sensors, to measure the load which is flowing through the bearing during the operation. And now this should kind of emphasize and underline that the WOT standard kind of fits in a sense of this, I think, what the initial standard also was to represent just products which you can, for instance, buy on Amazon, which are also sensorized. So IoT devices, and this is more an IoT device, so to say. But we thought in the very beginning that this is a good match, the standard, and what we tried to get from our products, to have it also in a standardized form. This is where we really went in the beginning, and this went very well. So we used the standard to create a kind of virtual representation of our products. And usually, how does it look like? So we have the life cycle on the left-hand side, where our products are engineered, they are produced, and they are then sent to the customer. This is the physical part. But we also shipped, so to say, the data to the customer. So basically, we had an interface to each of our products, which were sent to the customer using the WOT standard via a digital platform. And with that, the customers were really able to kind of interact with the product from Schaeffler. They were able to read the state. They were able to read the properties, maybe deviations during the production phase. And I think the response in the beginning was very good, because for us, it was also very good because it's a standard. So you just say you use the standard and the customer can read the docs, and they immediately know how to interact and use, let's say, the product. And this was, I think this went very, very well in the very, very beginning, till customers started also to bring up their own requirements on top of it. But this is something Sven will elaborate a little bit more in I think 2 or 3 slides. How, maybe just from that perspective, how did we do that? For sure, we had a data integration, let's say, layer where we kind of ingested all the data from the different life phases. We integrated it. This is something we won't go into detail today. And then this is explained here. We have developed a so-called WOTLib, so Web of Things standard library, where we do a things description. Also, we create a thing description as code, and this WOTLib is kind of generating the classes for it. And we attach mappings to a spoke, so basically a backend database. And with that, we can expose a REST API following the Web of Things standard. And the data integration part, I mean, this is not something that a topic of the day. This is exactly what I mentioned in the beginning. This is another product group which is handling that to bring everything together. But this is the way at the moment how we expose and we create web of REST APIs, so to say, which follow the Web of Things standard. And now Sven is taking over. So let me know when I should click.
Yeah, thank you, Christoph. So now we come to this. We call it challenges in this case because it's not really dealing with the standard. We have some, as Christoph mentioned, some additional requirements from our customers, how we respond or offer the data. And maybe Christoph, you can click to the first stage. Here you see some products of our side. As you see, they are nearly has the same properties. But our main problem is, maybe we can, with the first challenge, is that the customer normally not really want one special thing. He want to search, in this case, during the range or the bore, the diameter, and so normally we offer a list. So our normal customer
don't want to really use special for a special thing the properties. He wants to say, okay, let's give this for this range, and then return the list. This is one challenge that we have to to check or to fit. Maybe Christoph, you can to the next part. And this comes to this multi things. So let's reveal the customer won't not really say, yeah, this case gazillion of REST calls. So if some customers that buys bearings from us and they want to get the properties, and they buy maybe 10,000. But the properties are really the same. Only the identifier is different. And they say, okay, please, we don't want to call 10,000 times this REST call. If it's possible to get one REST call where we add all these properties that are special or defined for this, and you send us a whole list, so only the ID is changed, but the other part is fixed. This is one challenge we have to deal with. Please do the next part. And the analysis part in this case. Yeah, one challenge is that the user want some analysis on different process, so or products. So please send me some information where the bore diameter is maybe from 12 to 14. How many bearings have I bought this case, and so on. And this is, yeah. So next, please. And the last one, I think, is for this page. Yeah, and as I mentioned, we have many properties on many things. So every bearing actually is a thing. We have a constructor template where the designer said, okay, the bearing has to look in this case, and then every productive bearing is a thing. And this can to be millions in this case. So please to the next page. Yeah, and here's you'll see this is nearly the same. And yeah, the things property don't change. We have this is what I mentioned. We have this templates, where we have really fixed values, but only, as I mentioned, the ID has changed. And this is actually how to deal with this. In this case, virtual physical product. We have this product, also this template is our virtual product, and then we have this millions of producted elements that is also digital things, but it's only an instance, like we have a class definition, and we have an instance of a class in this case. And how we deal with this, actually, it's very hard because we have this millions of elements, and therefore we decided to go to this offer a search and not directly go to the special ID. Yeah, and this is the next part. Most of our customers really use the things description and not the data in this case. They really want, as I mentioned, this description and not really all the data. And we have to think about how to deal with this. And since the next question is normally from developer is, do you have Swagger or Swagger Jumble or something? And actually, we have not found any tool this created from the thing description directly the Swagger Jumble. So actually, we have implemented in this case, but the next challenge is that we have to customize the Swagger. So not every customer has to see all properties of a thing, so that we have really maybe actually for example, we have 5 customers. One have to see all, and C4 have special interpretations. And we are not allowed to say, okay, this property exists to it. So we have really to remove this property from the Swagger YAML and send it to the customer. This is the next problem that we have. We have really to let's call it one thing description, but with different views for the customer. Yeah, and the next is our customer use the WT standard, but they actually they use it because it's a REST call, and they can with the JSON, and they can process it. But nevertheless, it has also be a normal JSON. yeah, this was a quick view of our challenges. So feel free for answers or to questions. So hopefully that we can get an answer of it.
Yeah. So thank you for your attention.